So as art engines, how many of you are familiar with festivals like WAF or World Architecture Festival, all those things? Okay. In recent years, DIALux Evo used to be a very simple software. They really did a great job in developing this tool in the last few years. Now it's a very sophisticated tool. You can do whatever you want with it, really sophisticated. You can use it for artificial light design, can use it for daylight design, you can do whatever you want with it. And it has a lot of different components. We're going to cover them. I am going to, during the tutorial, I'm going to cover those items. You don't have to use a lot of them for your assignment, but it's good to know them because later on in the industry, you know what they are, how to use them, how to modify them. Okay, so whatever I tell you in this tool, I'll tell you what the typical values, rules are for your assignment. But then I'll also tell you how you can change that. And at the end of the course, you're going to use the luxmeter to learn a few important things when you're measuring illuminance levels. Okay, so let's get us started. You have different options here, similar to Comfin. Well, this is the third time my battery is falling down. Okay, there we go. So you have different options. What we are going to use is outdoor and building planning because that's really what we want. This tool is very sophisticated right now. As architects, you might know that the industry might be using, for example, Revit files, AutoCAD. You can easily import all those things into this tool and then carry out daylighting simulations on them, right? So let's start. The first thing we want to do is to learn what the general interface is. There's a lights inversion. We don't care about it. Calculations are carried out here. Here are a bunch of objects a bunch of items that we will go through. And here is the mode that you are working in. Important part is here, if you have never worked with 3D simulation software before, these are the important part. There is a 3D view, there is a plan view. This one is 3D, this one is plan. And the other one is display plans, and the other one is side. What is important to us is that when we want to draw the building, if you click here, draw a new building, you can see that it writes like dimensions and everything easily. Then I just want a perfect cube here. There we go. This is created. But now if you go to the solid part, this is a pretty solid thing. You want to draw new indoor contour. Contour lines make the geometry from a solid geometry to a hollow one, which inside becomes actually a room. Now, within, it says room 1. We have the room. How do we know? If I go here, I turn it up with left click only, you will see inside is empty, bottom empty. Remember, this tool is smart, so it removes the ceiling or floor depending on how you're looking at the building. The ceiling is there, the roof is there, and the floor is there as well. It just removes it so that you can see inside. Then there are different options. I'm not going through them because you do not want to create a sophisticated model, but just remember that there are a lot of modeling tools there. You can create outdoor contours, new empty stories, duplicate stories, and all those things. You can change the name here. Before drawing the new building, when you press this, you can set the height or you can set the wall thickness. Now, back to where we are. You can also modify your building because of the properties it has, as you can see. Floor thickness and all those things can be changed. Is it important? You just put it to the typical numbers, probably 3 meters ceiling. If you're measuring the library, probably 4 or 5 meters, and then you're good to go. But you can change a lot of things if you want. Now, this first one is actually the draw new building. So we normally, once you create the room, you really do not care about this option anymore. The first option is for importing. The next important option is here for windows. before continuing, does anyone know how we determine north in these tools? Perfect. Knock on the table, folks. If you see this corner, it's just a coordinate, and it shows you which one is north, which normally you look at it like this, and that would be your north. You can also draw a north symbol here. Later on in the tool, I can show it to you to make sure that you'll remember where it is. But for now, we want to create a window on the south-facing wall. You can see that there are dimensions here similar to Confan. I'll put it to 2 frame beat. I'll put it to 0.1. The seal height, 0.8, 0.9, depending on the standards you're using. Now, we have an option that says position active aperture. You click that, you click on the wall, the aperture is there. It does not always do a great job. You can modify it later on. I will just place Control Z. That's removed. Now, we can also draw a new aperture. You just press on the wall, and it will use the height you have here automatically. You can lower it to represent what you have. This one is not a good one, so I'm going to remove this. I'm going to change the seal height to 0.1. Then I will draw a new aperture. There we go. Now, this is how you create this. You can choose different window types here. You should choose it before drawing the aperture. But again, this is more of the sophisticated components of this tool. So we're not really going to use it for this assignment, but just be advised that you can use it. Just for the sake of demonstration. That's it. Okay. So now let me add another aperture here, and then because we all want to show you something. I think it positioned it on the floor, which is nice if you're designing a home on a ridge or a cliff and you want to see the sea. Might work, but we really don't need it right now here. Okay, it's not using the wall. Which I don't know why. Anyways, doesn't matter. We can do it later on. Remember this, if you remember, Confin had shades, blinds, and everything you could use with the windows. In this tool, you have exact same thing. I told you in the beginning of the class that once you learn the components of daylighting, it's almost the same in every single tool. You don't know a tool, you just know the components. You know that you can look for them and learn where to find them. Now, we can use shades. They're internal, external, and then we have the combined option here, which says internal blinds. I'm going to use an external one for this one. And as you can see, once selected, you click Add Facade System. Now you have a very sophisticated tool here. It says in the layer configuration on the left pane, you see where the mouse is. It says outside, you have the external wall, and then there's glass. You can change the position of this. You can fully open it. You can partially open it. You can fully close it. You can change the angle as well. Alignment can be changed as well, right? You really don't have to use it, especially if you don't have it in where you're measuring, but you can if you want. Now let's add an internal as well. This is an internal shade. I select the same window, I add facade system. And as you can see, this is outside, this is external blind, this is glass, and this is internal roller blind, which is inside the tool. Again, you can control how that is working. If you want to change them, you just need to select them and then change them. Now, Let's go to the properties. There are two important ones there that we normally work with: reflection factor, degree of transmission. What they are, let's go on the board and see what they are. Imagine this is your window. And this is the window we have here. The daylight you have or receive on this window, parts of it will pass and go through this room. That one is transmission, which is transmitted through the window, and part of it is reflected. Normally, double clear glass has a transmission value of 0.88. That's for double clear. If it's low E or something else, it will be different, right? So normally double clear is about 0.88. Some people use 0.8 as well, depending on how they measure it, whether you're using it and everything. Okay, so we have the same value for the wall. For the walls and floors, it's going to be different. With the lux meter, we are going to have a very interesting experiment. You will see how these reflection factors are actually going to work. That would be interesting. We'll have a tangible example. So I'm just quickly going through it right now here, but the rest of it are just drawing options. You can change the roof, you can change the floors, everything. The important part is this furniture, this table one, which is where you can actually draw furnitures. That's, for example, where I'm going to be studying or something, right? And you can work on it there. These, you can change the materials here in case you want. As you can see, the wall has a reflection factor of 50. You can change it if you want. You can change the material. Does not matter at the moment. And the rest of it, these four last ones, are what we call them in architectural tools, guiding lines, or they call it in this tool something else. They are used to just pinpoint the stuff in the simulation tool. They're not actually used for any calculations or anything, just help you to have coordinates of where to place other things, right? So again, the important part for the simulation here is the site where we draw the building, windows, and the blinds. That's all you need to remember. The rest of it was extra components for your information. The three things you just remember: site, window, and the shades. Now, next part is light. All these first ones are lights and stuff. What we really care about is this last one. And what we want to do is that we want to create an empty light scene. This create empty light scene, you click it. There's a light scene too. You can change the number. I'll just call it empty class for our classroom. Now, for daylighting simulations, remember, these are the important parts. For daylighting, we have reference sky type. I will describe what the sky types are. We have clear, average, and overcast. We have date and time. You can change it depending on the day you are measuring. And if you have direct sunlight, you will click direct sunlight here. For location, make sure that location is almost matching where you want to be. I assume there is a Ottawa here. There definitely was because I saw it before. There we go. So this is Ottawa, and the date and time Eastern, done. Let's go back to the light. Now, we are going to cover three important things. Pay close attention. I'm going to describe them on the board. It's about maintenance factor, types of a sky, and a few other things. Now I'm going to pause recording here. So I very clearly defined what the maintenance factor was on the board. going back to the lights. And here again, so as I described on the board, we have the clear, average sky, overcast sky. Overcast sky does not have the direct sunlight. Average sky and clear sky, they both have it. Make sure that you select one of these when you're carrying out your calculations. For light values, you can dim. You have options for dimming values for these things. Remember to make sure to tick this one for calculations. It's important when you want to carry out calculations. That's your that's your scene. The rest of it again are some informations that you normally do not use. You have a calculation object. We will go through it later on, but now let's carry out the calculation. And it says calculations. You press these two icons. I don't know why they created like that. I have no clue how that one is carrying like a calculation thing, but they did it. Perfect. This is the building we have. These values we have down there, they're used by the industry to represent the maps. They help you to read the simulations. This one is easy. You can just read the number. But imagine you're dealing with a hotel. You'd imagine you're dealing with a luxury villa, which has a lot of rooms, different components, different height, and everything. Reading such colors will help you to change that. You can change this to 50. Actually, because we are using blocks, let's put it to 300, that it matches our range to 2,000. Now, how we're going to do that, we go to the calculation object. This first one. Once we press it, which give me a second. Before showing you the map, if you press documentations, it's going to generate something which you're actually going to use for your assignment. There we go. And that is this lux level calculated. And for now, you see that this is not passing the minimum 500 lux, which is in the documentation. This is what you're going to use for assignment to measure how the building is operating. Now let's go back to the simulation. So this is it. And then this is the grid, guys. This grid shows where illuminance is at every single point. Okay. We had this working plane. I don't know why it is not showing the false color map. Okay. Now, before continuing, let me, I will rerun it to see what's the problem is. Remember, when you come to calculation objects and you go to this first one, you can set the height here. It's to 0.8 right now. You can change it to 0.76 as well, but in your assignment, it's actually asking for 0.8, so you don't really need to change it. Later on, if you want, you can change it from here. Remember that one. Let me... Oh, no, it is showing it. It's just not visible from the... It's not removing the top of the window. I don't know why. So as you can see... Oh, perfect. Thank you so much. Thank you. That's a lifesaver. So as you can see, the window is very small here because of the sun direction. There is a small sun going on. And then this entire thing is blocked with our blinds because we closed everything. Right? So in the false color map, as you can see, the closer we are to the window, the colors are higher, representing more light. And as you get to the bottom of the room, they get lower and lower. Is that clear? That's a false color map. And now, remember, you can change the grid size as well. When you are measuring stuff in reality, you are probably sticking to those guidelines for measurement. You can change those values, and those values are changed from here. When you select the work plane or the measurement plane, you can change it from this section. That's right now it's automatic. You can do it with quantity. You can, for example, you measured only 3 points by 3 points. It will reduce it, as you can see, to 9 measurement grids in DIALux Evo. And that will represent your room. Does measurement points have to match reality of what you measured in library? If you were going to calibrate a model, yes. For the assignment, you are not really asked to calibrate anything. So simulation can just carry out for 1,000 points, right? But if you're calibrating something, you want to get, for example, one of those weather data files for today from International Airport, and then make sure that those grids are matching what you actually measured in reality, and make sure those numbers are matching, or at least fall within an acceptable bias. All right? Is that clear? Okay, perfect. So that's how you change the grid as well. The rest of it is not really important. Just let's quickly carry out another simulation by changing this thing, and then we will get into the lighting mode. And yeah, and remember, as one of your classmates said, make sure that this is the story. It shows the top. Now, quickly checking this window and the changing the blind, we are going to remove, not removing it, actually, or half opening it. Okay, so roller blind was completely closed. We don't want that. And this is the last calculation we will have. Then we are going to work with the lux meter, and we will have experiment going on to see that engineering actually works. Perfect. Now you can see what the room is looking like. Let me describe it on the false color map. The same map is used most, like not this map, but we have I think in English they call it fish eye lenses. They are those lenses that make circular photos of the rooms, and then on those they can see how much light is where and whether it's causing glare or not. So referring to your earlier question, for like 500, depending on one of those cameras where you said, it can show whether there is a glare or not on the sun direction. As you can see, in the front of the window, because of the time we have, it's at noon. There's a lot of light here. It's south facing, so there's a lot in here. Down there, you don't have enough light. So according to what we have and this map as a guide, do you see that table in a good range for studying? That one is probably sitting around one of these purple ones. It's like 300, 375. On the lower end. It's on the lower end, right? It's on the lower end. It's not perfect, but it passes the minimum. If you go to the end of the room, it's almost zero. Not a good idea to study there. Here, it's nice. You can have your coffee and just enjoy your book, reading a book or something. Again, why do we use grids and multiple measurements in the room? Because as you can see in the false color map, the illuminance level in the front of the room is a lot, whereas in the back of the room, there's almost, in some point, it can reach below 50. This really dark one is at 12. That's why we have grids in the room, and that's why we measure things. Right? One of your classmates asked about measurements for with artificial lighting. I can briefly go through that after this, and then we will use the lux meter to carry out a cool experiment. Is there any question on DIALux Evo? Did you learn where to find the illuminance level when you're carrying out simulation? It's in documentation, illuminance level. The available information on it is, it provides you a summary, it shows that. It's updating. You see, it shows the contour lines, it shows the table and everything. Where you can find it is this 500 lux. Now, what was the impact of the blind? A roller blind, one of those that we have in most of our rooms, closing it completely means you are creating a very dark space, which is useless. What might be helpful at some point to block some excessive light? Right now, we left 25% open. Probably if we left the whole thing open, the external one, it was probably going about 2000. You can give it a try later on as well. Right now, it is passing the bare minimums, and you can see how it is happening.
Did you apply any artificial light into your model?
No, but you can do it in the artificial lighting later on.
Depends on the place that you are.
Yeah. So when you okay,